Okay. All right. Hey, everyone. So my name is Petros. I'm an engineer at Two Sigma. Today I'm going to be talking about fusing Bazel. And it's not necessarily about making Bazel itself faster. It was making incremental builds faster at Two Sigma, and then maybe additionally making a small optimization to Bazel. So the contents of the talk, right? And during the first part, we'll kind of discuss how and why we're using Bazel, and this will kind of be a testimonial from us, effectively. The short of it is that it's faster than what we have right now, and we're kind of optimizing for incremental builds, right? The second part of this talk will be about one performance optimization that we kind of like saw as a low-hanging fruit. It was a small little change to Bazel that potentially improved our incremental builds, right? And that was just modifying how Bazel computes its file digests, right? So before we get any further, so we have to give a disclaimer that this is not any sort of like investment advice. This has nothing to do with securities, all right? So that's a huge disclaimer, right? And you might be asking yourself, why we had to do this, right? So let's kind of take a step back and get a sense of who we are, right? So I'll be talking first, and then during the second part, Gabe will be talking. The two pictures that have been chosen were the ones that we use on GitHub, so if we make any sort of pull request, you have something to kind of associate name to face, name to picture thing going, right? So I work on the SDLC artifacts team, and what we do is we just basically manage the build and test farm at Two Sigma and all sorts of source control and things of that nature. Gabe will join us later on, and he was our intern this summer. He worked on the actual work to optimize Bazel, right? And he's going into his junior year, does majoring in CS and stats, smart kid, so, or guy. So who we are as a company, we're in finance. Some may refer to us as a hedge fund. We do a variety of like financial things. So that's a crux of who we are, right? So let's get into the interesting stuff, right? We commented on like how, this first part is about how and why we're using Bazel, right? So let's get a sense of what our development environment is like right now and why we want to switch. So right now, we have a very large monorepo, and we maintain multiple different languages. We primarily use Java and Python. We maintain our own dependency management system, and we have a notion of a project which can have multiple different languages. We have about 9,000 of these modules or projects, 4,000 of which are external dependencies, some of which are precompiled, some are built from source, right? So you have some sense of what the source control is like, right? What about build and test? What is the scale in terms of how many builds and tests that we do each day? Each day we do roughly about 15,000 build invocations, so like builds of the entire monorepo. And then that kind of breaks down into about 275,000 build actions. And overall, over the entire company, we do about 7.5 million tests. And then this is spread across a remote build and test farm with about 6,000 cores. So in this, I've commented about this thing called build actions. That's not the same build actions that is typically associated with Bazel. So this kind of leads to the next part. So right now, we're not officially using Bazel for everything. We're still migrating over. So what is our existing build system? It's based around Make, and what it does is that it has a different build script for each of the different languages that we use. So all the JVM languages use AND. For C++, we use GCC, and then we have various interpreters and transpilers for JavaScript and Python, right? And one huge problem that we face on this front is that it's quite slow, and it's also really hard to maintain. The second part, it's much smaller in writing, but it's a huge pain point. And so because of the slowness, what we ended up doing a few years ago was create a build and test farm, right? And as I said before, there's about 6,000 cores, and this was supposed to make things faster, and we additionally maintain a content addressable store with all of our build artifacts, and that we maintain some sort of like mapping between version of the monorepo and content addressable store, right? But again, we come into the same issue where it's still slow, and it's harder to maintain because you have more things that you have to maintain. And so Bazel kind of fits in for us here, where what we want to do is basically kind of throw away the existing build system and move on to using Bazel entirely, right? There is one complication there. As we make this migration, we want to ensure that we're not disrupting anyone. So what we've done so far is that we've just migrated just the Java code to build with Bazel. And it's kind of counterintuitive because we're having make invoke Bazel, but it is what we're doing right now. And we've kind of predicated migration where teams have to opt in. We do not forcibly migrate them over. And we're trying to get it to where the builds are so fast that they are incentivized to migrate over. And so I've commented about our goal of getting it so fast that people voluntarily migrate over. How have we done as far as maintainability and speed? As far as maintainability, all of you guys here have made it a significantly easier job. We previously had a team of maybe 8 or 10 engineers. At this point, with Bazel at least, you have engineers across the world working on this constantly and ensuring that it's performant, reproducible, correct, right? Now, as far as speed, the slides demonstrate one critical service that we maintain, that our team maintains. And you can notice from the incremental builds how much faster it is to build with Bazel rather than to build with what we were doing with make. It's obscenely faster, right? And that's exciting. And we're hoping that more people will see this internally and then from there just voluntarily migrate over with our assistance, of course. And as far as our general progress in terms of migration, from what we're about like 3,500 modules that use Java code, we have about 275 that have been migrated over. And most of those are things that we've owned as well as one other team. OK, so I discussed how we've seen some great speed gains and specifically incremental build speed gains for things that we've migrated. Earlier this summer, we noticed that we could get more improvements. And so we thought, let's look at how Bazel identifies whether a file has changed. Can we modify that in any sort of way to make it faster? So taking a step back, currently, what Bazel does is that to determine whether a file has changed or not, it just goes in, it fetches the file's contents, and then it computes a digest or a hash of the file. And this differs from other build systems like make, which kind of maintain a timestamp and check if the timestamp has changed or whatever. And then after it computes this digest, it then diffs against the existing digest it knows of. And if there's a difference, then clearly it's changed, right? And this is fine in general. But there's one problem for us. And the problem is that most of our files are not actually on disk. We actually mount them over the network through a fuse mount. Now you might ask why they aren't on disk, right? The reason why we mount most of our files over the network is that, again, we have a huge monorepo. Developers may only work on a small subset of that monorepo, and they don't necessarily need write access to the entirety of the monorepo, right? So there's source control issues in terms of having to check out everything. And so what we do is they access just a subset of that. Additionally, alongside the source code, there are the build artifacts. This is a general problem for any sort of, say, remote caching or remote build, right? If you build something, there's going to be a lot of intermediate output. If you're going to go in and fetch all of that intermediate output, that has network costs, right? And it'd be ideal if we didn't necessarily do that. And so in addition to exposing the source files over a fuse mount, we also expose build artifacts. So those are our motivations for why we're doing things on fuse. Now stepping back, why is it not ideal that Bazel is fetching the entire file content and computing a hash on that? So if you look at the diagram above, right, all Bazel is doing is just kind of wanting to identify whether a file has changed, and it's fetching all that content. It'd be nice if it just fetched the digest, which would just be a hash of the file, rather than get everything in the file. And for large files, this is an issue. And Bazel wants to do this for all sorts of files. So we thought, OK, let's figure out a way to kind of expose the file digest to Bazel in an intelligent manner. And this is the work that Gabe did this summer. and I'm going to pass it off to him to discuss how he implemented this.
Thanks, Petros. Hi, everyone. Yeah, so one thing that we thought was really important is to not just expose this file digest in kind of like an ad hoc manner. So not just like add some random API to our views, but do this in kind of like a standardized format, and ideally like POSIX compliant as well. So yeah, so our proposed solution is to expose this file digest via a user-defined extended attribute. So Google actually does this internally with Blaze and SourceFS. This is a bit.ly link that you guys can go to and see a whole blog post about how Google does their build system in the cloud. It's a bit dated, but so yeah, so our goal is to expose it via an extended attribute. So what actually is an extended attribute? It's basically kind of like a key value store you can associate with an inode in a file system that allows you to kind of just associate metadata that the file system doesn't actually interpret. So POSIX access control lists are implemented via extended attributes on some file systems, for example. Yeah, so what modifications do we actually need to make? What glue code do we need to write to connect Bazel and the fuse system? So first we got to modify Bazel and the fuse. So let's take a step back and kind of talk about what's kind of going on behind the scenes when we try to get information off a fuse mount. So say we want to either cat or get an extended attribute from some file. So the Bazel in user space is going to make a call out to the virtual file system in the kernel. And the kernel will decide whether to talk to the fuse driver or talk to the kernel-based file system for the file contents. And then if it's on the fuse driver will then make a call out to the fuse daemon that's running in user space, which will then communicate over gRPC to our content adjustable store. And then that either the digest or the contents get transferred all the way back to the daemon, to the fuse driver, to the kernel, and then to Bazel. So let's talk about the fuse. Fortunately for us, all files are immutable on our content adjustable store. So it's write and read, but the write only happens by the build farm who's uploading the build results and the source files. So to a developer, they only read these files. So the only part that we actually have to implement the extended attributes for are reading and listing. So no setting and dealing with state inside the file system, which is fortunate. So yeah, so we kind of expose this just as a user-defined checksum. And then to Bazel, the changes we needed to make was basically kind of write a new virtual file system layer or class that would instead of patching out natively to get this extended or to get the contents of the file and then compute a hash, it would just recognize that the file path is working on the fuse and make a call to the extended attribute to the native extended attribute code. Yeah. So let's look at some brief results. So if we set up a test and we look at kind of 1,500 files that Bazel ends up trying to get the digest for a specific build. So we kind of took one Java code base and looked at all the files that Bazel would ever get the digest for, right? And if we look at the time that it takes to get those hashes, just downloading and then computing a hash via like command line tools versus reading the digest off of an extended attribute, this is the kind of distribution we see. So this is like a distribution plot, and this is a bar plot of kind of the same thing. So you see that when we're downloading the file, the times are actually really like much with a much higher variance, which makes sense because it takes longer to download a file of 100 megabytes versus a file of 1 kilobyte, right? But for extended attributes, it should all be the same because we're just sending over a fixed size hash. Yeah, so it's much less affected by how much network bandwidth we have access to. But if we look at builds, we see a much different story. We actually don't see much of a difference, except maybe up on the upper percentiles. So why is this, right? So why do we see much smaller of a build improvements when we know we're actually downloading like much less data? So possible cause is that this actually isn't a throughput issue at all. It's a latency issue. So the time that we spend getting these file digests is not actually spent in downloading downloading files over and over again. It's spent just making calls to the kernel and then to the daemon and then out to our content adjustable store. So maybe the cause is just making those connections at all. And another issue is that our fuse daemon might be a little bit chatty. So to actually get the digest of a specific file, it has to make several round trips to our content adjustable store. It's not just one call. Another cause is that right now, the way that we develop at 2 Sigma, all of the developers work on remote machines. There isn't like there's no like local development machines. So those developer remote machines are actually co-located with our build and test farm. So it's possible that there's no like latency or throughput issue at all because it's just like it's co-located and we have like really fast interconnects between the machines. So the speed just really isn't a problem for us. But it could be a problem for people who have separate build farms and developer machines. Yeah. So then I guess I'll invite Petros back up and we'll kind of talk about the community impact of our work.
So in general, this was supposed to be a testimonial of sorts. We have been working on Bazel for roughly 1 to 2 years, kind of like off and on. We've had our existing build system is pretty intricate and pretty bespoke, and this migration has been one of the more challenging ones. And so we thought it was useful to kind of give a sense of where we're coming from, why we were interested in what was attracting us to Bazel. The second thing is for remote execution. So as you guys probably have noticed, there's been, 2 talks already today about remote execution. There's going to be more tomorrow. So over maybe a 6 to 7 year period, we built up our own remote build farm as well as our own remote cache and content addressable store. And so eventually we kind of led ourselves down the route of going this fuse mount route. Other approaches have also been introduced or proposed, such as like a remote file action system. There's a general problem, as I mentioned before, that Bazel has a lot of intermediary outputs, especially when you do a remote build. And having that be fetched over a network, all of that's a problem. There's network costs on that front. And so we presented one solution. There are other solutions, and hopefully if we could you could use this as inspiration of sorts. The changes have not been upstreamed. The reasoning being that at the time of writing this, there was a considerable amount of flux with the whole Blaze module system. But we've learned recently that it is stabilized in some respects, and that it's more pluggable. And so there is more interest. We are interested in kind of upstreaming our changes because then we don't have to maintain it. And we can bounce off of what George was saying and give a PR and merge our changes. So, good. That's the extent of our talk. If anyone has any general questions, say with our migration experiences or with Fuse, feel free to reach out to us. The entire team's here. So.